Hi students, welcome to Teachers Forum online classes. Today we are going to discuss about the first chapter in mathematics, that is real numbers. And the first topic we are going to discuss is Euclid's division lemma. Let us take some examples to understand what is Euclid's division lemma is. Okay. Now let us take two numbers. You can take any number. You take for example 32 and 7. These are two positive integers. Okay. Let us name 32 as A and 7 as B. So you are given two positive integers A and B. Okay. A is 32 and B is 7. Now let us divide 32 by 7. Let's see what we get. When we divide 32 by 7, 7 goes 4 times in 32. 4 7s are 28. The remainder is 4. So 32 can be written as 32 is equal to, you know that 32 is the dividend, 7 is the divisor, 4 is the quotient, 4 is also the remainder. So 32 can be written as 32 is equal to 7 into 4 plus 4. This 4 is the remainder, this is the quotient, this is the divisor, and 32 is the dividend. Now let us take another example, 24 and 9. Let us take the example of 24 and 9. These are two positive integers. Okay. Let's call 24 as A and 9 as B. Now let us divide 24 by 9. 9 goes 2 times in 24. 9 2s are 18. What is the remainder? Remainder is 6. So 24 can be written as 24 is equal to 9 into 2 plus 6. That is, dividend is equal to divisor into quotient plus remainder. Actually, this is Euclid's division lemma. It states that if A and B are any given two positive integers, there exist two integers Q and R such that there is a relation between A, B, Q and R. The relation is A is equal to BQ plus R, where the value of R will be less than B or greater than or equal to 0. This is known as Euclid's division lemma. For any given two positive integers. For the first example, what we have seen, the two positive integers are 32 and 7. A and B. If A and B are two positive integers, there exist unique integers Q and R. Can you tell me here? This is A, 32, 32 is A, 7 is B. Now what is 4? 4 is Q, and what is this 4? This is R. So 32 is equal to 7 into 4 plus 4 can be written in the form A is equal to BQ plus R. Okay, so Euclid's division lemma is nothing but the process of long division. See, let us see what is in the, let's say the second example. It is given two positive integers 24 and 9. Okay, 24 is taken as A and 9 is taken as B. Then 24, when you divide by 9, 24 is A, what is 9? 9 is B. What is Q here? Here Q is 2. And R is 6. So this also can be written in the form A is equal to BQ plus R. This is known as Euclid's division lemma. If A and B, two positive given integers are given, there exist two unique integer Q and R. And there is a relationship between A, B, Q and R. that is given by Euclid's division lemma, that is A is equal to BQ plus R, where R is the remainder, so it should be always less than B and should be greater than or equal to 0. This is known as Euclid's division lemma. I think it is clear. So given two positive integers A and B, there exist unique integers Q and R such that A is equal to BQ plus R. This is known as Euclid's division lemma. It is nothing but the process of long division, that is dividend is equal to, what is B? B is the divisor. Divisor into, what is Q? Q is the quotient. Divisor into quotient plus R. R is the remainder. Okay, this is known as Euclid's division lemma. Now let us see what is Euclid's division algorithm. Euclid's division algorithm is a technique to compute the HCF of any given two positive integers. Okay, so it is used to find the HCF, that's all. Now let us take some examples to find the HCF of any given two numbers using Euclid's division algorithm. Okay, now let us take the first example as 2, 10 and 40. So these are two positive integers 2, 10 and 40. Let us find the HCF of 2, 10 and 40 using division algorithm. Okay, now let us divide. The larger number is 2, 10. So let us divide 2, 10 by 40. So 40 goes 5 times in 2, 10. So 5 40s are 200. You subtract, you will be getting 10 as remainder. Okay, so this step can be written as, according to Euclid's division lemma, this can be written as, what is Euclid's division lemma? According to Euclid's division lemma, A is equal to BQ plus R. This is known as Euclid's division lemma. Okay, now here A is 210 and B is 40. So 210 and 40 can be written as 210 is equal to, that is dividend is equal to divisor into quotient, that is 5, plus the remainder, that is 10. So this is in the form A is equal to BQ plus R. Okay, this is the first step. Now in the next step, this 210, here we have divided 210 by 40, you get 5 as quotient and 10 as remainder. Now in the next step, the remainder becomes the divisor and this 40, the divisor, become the dividend. Okay, now it will be clear to you after doing 2-3 problems. Okay, now the 40 becomes the dividend. Now let us divide 40 by 10. Now 40 goes, 10 goes 4 times in 40. 4 tens are 40. You will be getting 0 as a remainder. So this step can be written as 40 is equal to, that is the 40, in the previous step 40 was the divisor, that becomes the dividend. Now what was remainder in the first step, that becomes the divisor. So 10, 40 is equal to 10 into 4 plus remainder is 0. So what we have done here, from the given two numbers, you select the larger one, that is 210 here. So you divide 210 by 40. 40 goes 5 times in 210. 5 40s are 200, remainder 10. So here you can apply dividend is equal to divisor into quotient plus the remainder. So 210 can be written as 40 into 5 plus 10. Now in the next step, what do you do? You divide 40 by 10. That is, the divisor in the first step becomes the dividend and the remainder becomes the divisor. Okay, now you divide 40 by 10. This 40 you bring here. Okay, 40 by 10, 10 goes 4 times in 40. 4 tens are 40, the remainder becomes 0. You see, when the remainder becomes 0, what is the divisor? That will be the HCF of given two number. So what is the HCF of 210 and 40? HCF of 210 and 40 is equal to 10. Okay, now let us take another example. Okay, let us take 455 and 42. 455 and 42. We have taken two number. Which is the larger one? The larger one is 455. Now let us divide 455 by 42. Let us see what we get. Let us divide 455 by 42. 42, goes 10 times in 455. So 42 into 10 is equal to 420. What is the next step? You just subtract. What you will be getting? 5, 3, 35. So this can be written in the form 455 is equal to, that is dividend, is equal to divisor, that is 42, into quotient, that is 10, plus remainder. What is remainder? Remainder is 35. Okay, so it is also in the form A is equal to BQ plus R. Now what is the next step? The next step, what is the divisor? That becomes the dividend. So you divide 42 by, the remainder becomes the divisor 35, isn't it? Now let us divide it. Now this 42 becomes the dividend and the remainder becomes the divisor. Now 35 goes once in 42. So 35 into 1, 35. What is the remainder? Remainder is 7. So this step can be written as 42 is equal to 35 into, tell me, 35 into divisor into quotient. Yes, that is 1 plus remainder. What is the remainder? Remainder is 7. It is also in the form A is equal to BQ plus R. Clear? Now can you tell me the next step? In the next step, what will be the dividend? Sure, 35. 35 will be the dividend. What will be the divisor? Divisor will be the remainder 7, isn't it? Now let us divide 35 by 7. What you will be getting? That is a divisor becomes the dividend. Remainder becomes the divisor. Now you divide 35 by 7. 7 goes 5 times in 35. 7 5s are 35. What is the remainder? Remainder becomes 0. Now this step can be written as 35 is equal to 7 into, that is dividend is equal to divisor into quotient. What is quotient? 5 plus remainder. What is the remainder? Remainder is 0. Now the process stops here. So what is the remainder here? Remainder becomes 0, isn't it? When the remainder becomes 0, the divisor. That is called the HCF of the given two number. So here, what is HCF of the given two number? 455 and 42. What is HCF? HCF is equal to 7. I think it is clear. So what is Euclid's division algorithm? It's a technique to find the HCF of given two numbers. Okay, so here we follow certain steps. I think the steps are clear to you. Now let us solve some problems from the NCERT solutions, and after that let us solve some previous year's questions, okay, that has been asked from this particular topic. Now let us solve the first problem from the exercise 1.1. Okay, let us read the question. Now using Euclid's division algorithm, you have to find the HCF of the given pairs of numbers. Okay, so let us solve the first one and the third one. Okay, the first one is 135 and 225. You are given two positive numbers. You have to find the HCF of 135 and 225 using Euclid's division algorithm. Okay, now which is the larger number? 225 is the larger number. So let us start dividing 225 by 135. Okay, you know how to solve it. Okay, let us together do it. Now when you divide 225 by 135, 135 goes 1 times into 25. So 135 into 1, 135. When you subtract 5 minus 5, 12 minus 3, 90. You will be getting 90 as a remainder. Now this step can be written as 225 is equal to, that is dividend is equal to divisor into quotient plus the remainder, that is 90. It is in the form A is equal to BQ plus R. Okay, you know that the next step 135, that is the divisor becomes the dividend, the remainder becomes the divisor. Okay, now let us divide 135 by 90. So what was the divisor? That becomes the dividend. What is the remainder? That becomes the divisor. So 90 goes once in 135. So 90 into 1, that is 90. When you subtract 5 minus 0, 5. 13 minus 9, 4. So you will be getting 45 as remainder and 1 as quotient. So this step can be written as 135, that is dividend, is equal to 90, that is divisor, into quotient, that is 1, plus the remainder. What's the remainder? Remainder is 45. Now in the next step, the 90 becomes the dividend, 45, that is the remainder, becomes the divisor. Okay. Now this 90 here, the next step, what was the remainder? That becomes the divisor, and was the divisor, that becomes the dividend, that is 90. So let us divide 90 by 45. Now 45 goes twice in 90, 45 into 2, that is 90, you will be getting remainder as 0. Now this step can be written as 90 is equal to 45 into 2 plus 0. Now we can stop the process here. Why? Because the remainder becomes 0. When the remainder becomes 0, what is the divisor? That is the HCF of the given two number. So here, what's the HCF? HCF of 135 and 225 is equal to 45. I think it is clear. Now let us solve the second one. Here, two numbers are given, 867 and 255. Which is the larger one? 867. So let us start dividing 867 by 255. 255 goes, 2 times, if it is 2 times, it becomes 510 plus 255, 765. When it becomes 4 times, it goes above 1000, isn't it? So it goes 3 times. 3 into 255, 5 3s are 15, 5 3s are 15 plus 1, 16, 3 2s are 6, 6 plus 1, 7. Now let us subtract. 7 minus 5, that is 2, 0, 1. So 102 is the remainder and 3 is the quotient. So this step can be written as dividend is equal to divisor into quotient plus remainder. What will be the next step? The next step, the divisor becomes the dividend and the remainder becomes the divisor. Okay. Now let us divide 255 by 102. So here 255 becomes the dividend. Let us divide 255 by 102. 102 goes twice in 255. It becomes 204. When you subtract, you will be getting 51 as remainder. So this step can be written as dividend is equal to, that is 255 is equal to divisor 102 into quotient plus the remainder 51. Okay, it is clear, I think. Now in the next step, the divisor becomes the dividend, that is 102 is equal to, the remainder becomes the divisor 51 into, let us see. Now let us divide 102 by 51. Okay, let us divide 102 by 51. 51 goes, yes, twice. 2 into 51, that is 102, the remainder becomes 0. So how can you write this step? This step can be written as dividend, that is 102 is equal to divisor into quotient plus the remainder. Remainder is 0. See, here the remainder becomes 0. The process stops here. When the remainder becomes 0, what is the divisor? That will be the HCF of the given two numbers. So what is HCF here? HCF of 867 to 55 is equal to 51. Okay, I think it is clear. Here we have to show that any positive odd integers are of the form 6q plus 1 or 6q plus 3 or 6q plus 5. Okay, so let us take A as any positive integers. Okay, any positive integer. AB, any positive integer. Now it is of the form 6q plus 1 or 6q plus 3 or 6q plus 5. So it is in the form 6q plus 1, it is of the form bq plus r. Okay, now what is b here? Here the b is 6. According to Euclid's division lemma, A is equal to bq plus r, where the value of r is less than b or greater than or equal to 0. This is Euclid's division lemma. You know that. A is equal to BQ plus R. Now, here what is the value of B? The value of B is 6. So, what are the possible values of remainder R? R can be, that is less than B, that is less than 6, greater than or equal to 0. So, the possible values of R are 0, 1, 2, 3, 4 and 5. Isn't it? Because the value of R is less than B. So, it can be 0, 1, 2, 3, 4, 5. Now, when, let us see, what will be the value of A when R is equal to 0? Can you tell me when R is equal to 0, what is the value of A? What is A? A is any positive integer. So, when the value of R is equal to 0, A is equal to BQ. What is B? B is 6. Q is any integer. So, A is equal to 6Q plus R. What is the value of R here? R is 0. So, 6Q plus 0, that is equal to 6Q. Now, let us substitute the next value of R. When R is equal to 1, what is A? A is equal to 6Q, that is BQ plus R. What is B? B is 6. So, 6Q plus R. What is the value of R? Is 1. So, A is equal to 6Q plus 1. When R is equal to 2, what is the value of A? A is equal to 6Q plus 2. Now, when R is equal to 3, the value of A is equal to 6Q plus 3. When the value of R is equal to 4, the value of A is equal to 6Q plus 4. When R is equal to 5, the value of A is equal to 6Q plus 5. So, the possible values of R here are 0, 1, 2, 3, 4, 5. Now, A is any positive integer. Any positive integer is of the form A is equal to BQ plus R, where B is 6. So, when R is equal to 0, it will become A is equal to 6Q plus R. R is 0, that is 6Q. When the value of R is equal to 1, it will become 6Q plus 1. Then, when you see R is equal to 2, it will become 6Q plus 2. You see, 6Q, 6Q plus 1, 6Q plus 2, 6Q plus 3, 6Q plus 4 and 6Q plus 5. Now, let us see what is 6Q, what is Q. Q is any positive, any integer. So, when you give the value of Q as 1, what you will be getting? 6Q. 6 into 1, 6. When the value of Q is 2, what is the answer? 6Q. 6 into 2, 12. When Q is 3, 6 3s are 18. When Q is 4, 6 4s are 25. When Q is 5, 6 5s are 30. It goes on. Isn't it? So, 6Q is 6, 12, 18, 24, 30 and so on. Any number. Okay. That is, you can multiply 6 with any number. Then you will be getting 6Q. Now, can you tell me what is? So, what do you conclude from all these numbers? All these numbers are even number. Why? It can be divided by 2. So, what do you conclude about 6Q? Even or odd? It is even. Now, let us see what is 6Q plus 1. Plus 1 means with this number you should add 1. What is 6 plus 1? 7. What is 12 plus 1? 13. 18. So, you have added plus 1 here. Okay. 6Q plus 1. It becomes 19. It becomes 25. It becomes 31. It goes on. Is it even or odd? It's an odd number. So, what is 6Q plus 1? 6Q plus 1 is odd. Now, let us see what is 6Q plus 2. Let us add plus 2 here. 6Q plus 2. 6 plus 2. You add plus 2 here. Okay. What is 6 plus 2? 8. 12 plus 2. 14. 18 plus 2. 20. 26. 32. These all are even numbers. So, 6Q plus 2 is even. Similarly, what will be 6Q plus 3? Just you add plus 3 here. Okay. 6 plus 3, 9. 12 plus 3, 15. All these are odd numbers. What will be 6Q plus 4? 6Q plus 4 will be, you just add 4. 6 plus 4, 10. 12 plus 4, 16. So, 6Q plus 4 will be even. Now, what will be 6Q plus 5? That will be odd. You just add 5 with 6Q. These are the values of 6Q. Just add 5. 6 plus 5, 11. 12 plus 5, 17. 18 plus 5, 23, 24 plus 5, 29, all these are odd number. So it is given that A is any positive integer, the positive odd integer, odd integers are of the form 6q plus 1, 6q plus 3 or 6q plus 5. So here, see, what are the odd integers? Odd integers are of the form, this is odd, that is of the form 6q plus 1. Then this is also odd, it is of the form 6q plus 3. It is also of the form 6q plus 5. See, so all these are odd numbers. That is, any positive odd integer is of the form 6q plus 1 or 6q plus 3 or 6q plus 5. Can you tell me one odd number? Let us take one odd number, that is 47. 47 is an odd number. Okay. Now, let us divide 47 by 6. What will be getting? 7 6 are 42. What is remaining? Remainder is 5. So, 47, how can you write 47? Can you tell me? 47 is equal to 6 into 7 plus 5. It is of which form? A is equal to, see, A is equal to, okay, let us take another example. Okay, 47 you have taken. Let us take the next number, 49. Let us take 49. It is also an odd number, 49. Let us divide 49 by 6. 8 6 are 48. What will be getting? You will be getting the remainder as 1. So, how can you write 49? Can you tell me 49? 49 is equal to 6 into 8 plus 1. You take another number, any number, 17. Let us take 17 next example, 17. Okay, now let us divide 17 by 6. What you will be getting? You will be getting 2, 6 are 12. You will be getting 5 as remainder. So, 17 is equal to 6 into 2 plus 5. You see, these are all odd positive integer. These are odd positive integer, that is also of the form, see, 6 is common here. So, here we have taken A is any odd positive integer. Okay. So, these all are positive integer. So, this is A is equal to 6 is common everywhere. So, you can write 6. What is 7, 8, 2, etc.? They are Q, any integer. So, it can be written 6q. What are the number you got here? Say 47 is equal to 6q plus 5, 6q plus 1. You will be also getting 6q plus 3. So, any odd positive integers are of the form 6q plus 1 or 6q plus 3 or 6q plus 5. Okay. So, you just take any odd positive integer. You divide by 6. It will be of the form 6q plus 1 or 6q plus 3 or 6q plus 5. I think it is clear to you. Okay, it is just for your understanding that I explained this topic. Actually, this is just for you. Okay, actually this is the problem. Okay, so according to division lemma, A is equal to BQ plus R. Here, A is any odd positive integer, B is 6. So, when B is 6, the possible values of R are 0, 1, 2, 3, 4, 5. When you substitute R is equal to 0, it becomes 6q. When you substitute R is equal to 1, you will be getting 6q plus 1, then 6q plus 2 up to 6q plus 5. 6q is even, 6q plus 2 is even, 6q plus 4 is even. But what is given? A is any odd positive integer. So, the positive odd integers are of the form 6q plus 1, 6q plus 3 or 6q plus 5. Okay, now let us move to the next one. Here we have to show that using Euclid's division lemma, we have to show that square of any positive integers are of the form 3m or 3m plus 1. Okay. So, here let A be any positive integer. Now, what is the value of B? You know what is the value of B? It is given that it is of the form 3m or 3m plus 1. So, the value of B is 3. Okay. Now, what are the possible values of R? The possible values of R is equal to 0, 1 and 2. Why? Because according to Euclid's division lemma, the value of R should be less than B, that is less than 3, greater than or equal to 0. So, the values can be 0, 1 and 2. So, that are the possible values of R. Now, before solving this problem, let us take some examples. So, what is given? It is given that square of any positive integers. You take any positive integer, the square of any positive integer is of the form 3m or 3m plus 1. Just take the square of any positive number, okay, integer. Let us take the example of 5. What is 5 square? 5 is a positive integer. 5 square is 25. Let us take another example, you can take, 7 or 6 you take, 6. What is 6 square? 6 square is 36. Now, the square of any positive numbers can be expressed as, what is given? 3m or 3m plus 1. Now, let us divide 25 by 3. Okay, let us see what we get. When you divide 25 by 3, you will be getting 8 3s are 24, remainder 1. So, how can you write 25? 25 can be written as dividend is equal to divisor into quotient plus the remainder. That is 3 into 8 plus 1. Now, let us divide 36 by 3. So, when you divide 36 by 3, you will be getting, 12 3s are 36. What is the remainder? 0. So, how can you write 36? 36 can be written as dividend, divisor into quotient plus the remainder, 0. You take any other number, let us take 10. What is 10 square? 10 square is 100. How can you write 100? Let us divide 100 by 3. You will be getting, 3 3s are 9, 10, 3 3s are 99. You will be getting remainder as 1. So, how can you write 100? 100 is equal to 3 into 33 plus 1. So, from this what you conclude? 3 is common. If you take the square of any positive integer, see 3 is common everywhere. Okay, so 3 is common. Now, what is 8, 12 and 33? They are some integer, any integer. So, let us write it as 3q or 3m, whatever may be. Now, what is the remainder? Remainder will be always 0 or 1. Okay, so it can be either of the form. So, square of any positive integers are of the form 3q or, can you tell me, or 3q plus 1. See, the remainder will be always either 0 or 1. So, that is what we are going to show here. Okay, so it is that this, we have taken some examples to see that, square of any positive integers are of the form 3m or 3m plus 1 or 3q or 3q plus 1. That result we have to prove here. Okay, so we are going to show that the positive integers, square of positive integers are of the form 3m or 3m plus 1. So, here a be any positive integer and b is equal to 3. So, the possible values of r are 0, 1, 2. Let us start with when r is equal to 0. Can you tell me when r is equal to 0, what is a? A is equal to bq plus r. What is b here? B is 3. Q, some quotient, okay, Q is quotient or some integer, okay. A is equal to 3q plus r. What is r here? R is 0. So, it will become 3q plus 0, that is 3q. Now, let us see when r is equal to 1, what is a? A is equal to, again, is equal to, a is equal to bq plus r, that is 3q plus 1. When r is equal to 2, what is a? A is equal to 3q plus 2. But it is given that square of any positive integer. So, the positive integer a is equal to what? 3q, 3q plus 1 and 3q plus 2. Now, let us square. Let us find what is the square of positive integer. That is 3q square. How can you write 3q square? 3q square is equal to 9q square. See, you can divide, 9q square by 3. Then you can write it as 3 into 3q square. That is of the form 3m. What is m here? This is m. So, it is of the form 3m. Now, let us take the second integer, that is 3q plus 1. Let us find the square of this. It is of the form a plus b the whole square. What is a plus b the whole square? A square, 9q square, plus 2ab, 2 into a into b, that is 6q, plus b square, that is 1, that is equal to. What is common? You can take 3 outside here. First 2 terms can be divided by 3. So, let us take 3 outside. Then what you will be getting? 3q square plus 2q and plus 1. That can be written as, let us substitute this as, m, some integer. Okay. Now, it is can be written as 3m plus 1. Now, let us take the third one. Okay. That is integer is 3q plus 2. Let us find the square of 3q plus 2. That is 3q plus 2 the whole square. It is also of the form a plus b the whole square. What is a plus b the whole square? A square, 9q square, plus 2ab, that is 12q, plus b square, that is 2 square, that is 4. That is equal to, now let us 9q square plus 12q. 4 can be written as 3 plus 1. Now you see what is common. You can take 3 outside of the first 3 terms. It becomes 3 into 3q square plus 4q plus 1 plus 1. This is also of the form 3m plus 1. Okay. So the square of any positive integers are of the form 3m or 3m plus 1. I think it is clear to you. So what we have done here, a is any positive integer, b is 3, the possible values of r are 0, 1, 2. So the integers you got the you get the positive integers, a is equal to 3q, 3q plus 1 and 3q plus 2. But it is given that you have to show that square of any positive integer. So you have to just square it. 3q square, 3q plus 1 square, 3q plus 2 all square. Okay. When you square it, that can be expressed in the form 3m plus 1. That is, using Euclid's division lemma, we have shown that the square of any positive integers are of the form 3m or 3m plus 1. You take any positive integer, just find the square, you divide by 3, it will be always of the form 3m or 3m plus 1. Okay, now let us move to the next one. So in this class we discussed what is Euclid's division lemma and Euclid's division algorithm. Okay, I think the topics are clear to you. We have done some problems from the NCERT textbook from exercise 1.1. I think all these problems are clear to you. Okay, now only the practice makes you perfect. Okay, the more you practice, the more marks you can achieve in your board examination. So what you have to do is, you can just click the link given below and you can download the PDF. Okay, the similar questions, practice questions can be downloaded from the link given below, and you don't forget to subscribe our channel. Why? Because I will be coming with the next topic the next day. Okay, so to get the videos updated, you just subscribe the channel, and you should always, if you find it useful, you should recommend this channel to your friends. So have a nice day. Thank you.